To calculate the acceleration of the rod, we assume that it is moving at a constant angular velocity omega. The pin is located at a radius r from the center of the wheel, and our goal is to calculate the velocity at a point P, an arbitrary distance away from the center. As the wheel rotates an angle theta, the displacement in the x direction can be found using trig. This can be written as a function of time, with theta equals omega t. Differentiating this once with respect to time, we get the velocity of p as a function of time. And differentiating this one more time with respect to time, we get the acceleration as a function of time. As you can see, this is a sine function with amplitude omega square r. This means that the acceleration oscillates from positive omega square r to negative omega square r. Since we know omega, as we calculated before, we now have our maximum acceleration as a function of r. Plugging in 9.81 meters per second squared as our maximum acceleration, we found the desired r of the Scott shield.
To make our own Scott shield, we used MDF and acrylic. The acrylic wheel is press fit onto the rod of the motor, and a screw is attached to it to act as a pin. This screw interfaces with an acrylic rod that is supported by two pillars. It slides through the rectangular holes in the pillars that loosely enclose it. The acrylic reduces friction considerably relative to MDF. The pillars are press fit into an MDF base. The motor and battery pack are placed at a raised height with the help of MDF blocks glued to the base. It is press fit into the top block. A possible source of error was in our measurement of RPM. When we changed our gear ratio from 1:12.7 to 1:144, our audio analysis of the RPM was not working. This is because the motor itself was making a great deal of noise, and we could not distinguish the peaks of the cycle from the background noise accurately. So we calculated the percentage increase in the RPM for the lower gear ratio and applied this to our new configuration. There was a loss in accuracy here that made our motor rotate faster than we had anticipated, and so it affected the calculated radius.